Let us discuss another important law used for circuit analysis, that is Kirchoff's voltage law. About this we can say that this law is also termed as loop rule for electrical circuits. Sometimes this Kirchoff's voltage law is also termed as loop rule for electrical circuits because it is generally applied in a closed loop in the electrical circuit. And what this law states, let's first write down and then we'll discuss about how it is applied or how it is used. It states that in any closed loop of an electrical circuit, the sum of all EMFs of the loop and all the potential drops across all resistances of the loop is equal to 0. Just to understand what we have written over here, we have written that sum of all EMFs and all the potential drop across all the resistances in the loop is equals to 0. Now say we just consider a system in which there is a resistance, a battery given here, another resistance, there is another battery like this. And there is a closed loop here, say the resistances are R1, R2, EMFs are E1 and E2. Now in this loop, if we wish to apply the Kirchoff's voltage law, say the loop terminals are A, B, C, D, then we write in closed loop A, B, C, D, A. This A, B, C, D, A is a closed loop. Using Kirchoff's voltage law, we get, here say we start from terminal A, then from terminal A if we go to terminal B, here you can see that the battery of EMF E1 is having high potential terminal connected to terminal B. So at terminal B potential is E1 volt higher than A. So from terminal A if we are starting, we can say the potential is gained by an EMF E1. Now here if we consider a current I1 is flowing in this loop, and we know in the direction of current always potential decreases. So in this situation if a current I1 is flowing through the resistance R1, then moving from point B to point C, we can say there will be a potential drop in the resistance which is I1 R1, that will be reduced. So we can write it minus I1 R1. Again in going from terminal C to D, you can see there will be a gain in potential of EMF E2. So we can write plus E2. And again from D to A, as we are moving along with the current, there will be a drop in resistance which is I1 R2. We write minus I1 R2 and this should be equal to 0. This is the equation we call Kvl equation for this loop. This loop means this is what I have drawn here. So this is just a way out to write the Kvl equation, and solving this equation we can find out the value of I1 directly. Here you can see the value of I1 we are getting is E1 plus E2 upon R1 plus R2. So in detail about Kirchoff's voltage law we'll discuss in various examples, but on the next sheet I'll be taking another application just to explain you better how to write Kvl equation. To understand the application of Kirchoff's voltage law, let's consider a circuit here in which there are 3 batteries and 5 resistances connected in a manner. Here if we wish to analyze the circuit and we wish to find out the current in various branches of the circuit, first we'll consider currents in the given loops of the circuit. Like say if we consider these 2 loops, we assume that in this loop say a current I1 is flowing, and in this loop a current I2 is flowing. Here I am taking both of these current to be flowing in clockwise manner. However, just for application of KVL, you can take it reverse also, one clockwise, one anti-clockwise. But for calculation ease, it is always better to consider currents in same direction. Here, if I am able to calculate the values of I1 and I2, I can directly tell the current in each branch of the circuit, like in this 2 ohm I1 is flowing, 3 ohm I2 is flowing, in this 4 ohm I1 minus I2 is flowing. Like that we can easily calculate. So in this situation we just need to write KVL equations for the loop I1 as well as for the loop in which current is I2. So let's write for loop 1, KVL equation is, in this loop, say we start from one point, say these points are A, B, C, D and then E, F. So this is the loop going from A, B, C, D, A. Then from point A, if you move to point B, you can see whether there is a potential gain or potential drop. Here you can see that point B is connected to the negative side of the battery, so there will be a potential drop, so it will be minus 20. If you move from B to C, you are moving along with current, so there will be again a drop of minus 2I1 because the drop across the resistance is the product of current and resistance. If I move from C to this point, it will be a 4 ohm resistance and the current flowing in this direction is I1 minus I2. So I'll write minus 4I1 minus I2 because the drop in the resistance 4 ohm will be IR. So 4 multiplied by I1 minus I2 because I2 is also flowing in opposite direction. Now there is a 10 volt drop due to the battery. So we can write it minus 10. And then from point D to A will come, there will be a 3 ohm resistance and then current I1 is flowing, so it will be minus 3I1. This is equal to 0. So on simplifying this equation, you can see what we are getting. It will be 4 plus 2, 6 plus 3. This will be 9I1 minus 4I2 is equals to minus 30. This is the first equation for the loop, which is relating I1 and I2. Similarly, if we write for loop 2, KVL equation is, if for the second loop we write the KVL equation, and here say we start from point E and the loop is E, F, D, C, E. Here the loop was A, B, C, D, A, and here we are taking loop as E, F, D, C, E. We are starting from point E, then going from E to F, you can see there will be a drop in potential of 5 volts, so this will be minus 5. Then if we move further, it will be minus 5 I2. Then if you move up, this will be a gain in potential of plus 10. Then it will be a drop in potential minus 4 times I2 minus I1. Because I am going in this direction, so along the direction of current I2, there will be a drop and the current I will take as I2 minus I1. And then from C to E, it will be minus 3I2, that will be equals to 0. If I simplify this equation, you can see this will be 4 plus 5, 9 plus 3. This will be 12I2 minus 4I1 is equals to 5. This is my equation number 2. And from these two equations, I can see these are two equations and two variables I1 and I2. So very easily I can calculate the values of current in the two loops. So I can write solving 1 and 2 will get the value of I1 as well as we get the value of I2. So once we get the values of I1 and I2, we can tell the current in any branch of the circuit at once. So this is the way how KVL is applied in various circuits. So you must be very careful. Now we'll discuss some examples to understand the application of KVL and KCL in more detail.